In this video, we're going to be taking a look at two conversions within the metric system. All right, just to familiarize ourselves with a little mnemonic device, which will then help with those conversions. All right, so your metric prefixes from largest to smallest: kilo, hecto, deca, your base unit, and then deci, centa, and milli. All right, base unit being either liters, meters, or grams. So the chart will work no matter what actual unit you are using. All right, mnemonic device to help you remember this. Okay, so you don't have to write out the metric prefixes, and you don't have to use a fancy chart like this. You could just do the KHD, BDCM, and then after it's memorized, this will be a real easy, quick way to do the conversions. All right, let's say we're converting 6,000 milliliters to liters. All right, milliliters is the prefix of milli, so we would start right here. Liters is going to be that base unit. So in the chart, it's going to be 3 hops to the left. If I move 3 hops to the left in the chart, I'm going to move my decimal 3 hops to the left. So I'm going to take the number 6,000. All right, we all know that the decimal sits at the far right-hand side of that number. So when I do 3 hops to the left, it becomes that 6.0. All right, now for nursing in particular, all right, nurses are leaders, not followers. That's the way you can remember this. We definitely want to write 6 liters. We do not want to write 6.0. All right, 6.0 liters. Okay, that could be misread as 60. All right, so in the nursing field, we are going to just make sure that we do 6. Nurses are leaders, meaning any leading zeros before we would include. We are not followers, so any zeros that would fall to the right, we do not include. So you're going to write 6 liters. All right, in the second example, we're going to convert 8.1 kilograms to grams. All right, prefix kilo is right here. Our grams is going to be our base unit. So in my chart, I'm going to hop 1, 2, 3 hops to the right. So that means I'm going to move my decimal 3 hops to the right. So an 8.1, which is what I'm starting with, 3 hops to the right, 1 hop around the 1, and then 2, 3. All right, so then I've got to add some imaginary zeros in there. Then this is going to be 8,100 grams. All right, so 2 pretty straightforward conversions that you will have to be able to convert while doing your dosage calculation problems. In the previous 2 examples, I showed you how to use a mnemonic device in order to convert within the metric system. They were straight math problems. As a nursing student, you probably are not going to be asked just to convert within the metric system with no context in the problem. So what you're going to have to be able to do is to read the problem and then realize that, oh, all this really involves is a conversion within the metric system. So here we've got a nurse is preparing to administer vancomycin 2 grams IV daily to an adult patient. The recommended adult dosage is 500 milligrams to 3,000 milligrams daily. Is the ordered dose safe? All right, so the thing you are going to really need to focus on here is, okay, they gave you the 2 grams, all right, as what's being administered. The recommended dose is milligrams. So you can't just look at this and go, oh, well, 2 does not fall in that range, so then the answer would be no. You're going to have to convert one way or the other to ensure that they are in the same unit. Now, like I said, with that mnemonic device, you're probably just going to say to yourself, kittens hate dogs because dogs can't meow. So really, that's the only thing you need to write. Okay, now I've got 2 grams, which is the base unit. So here's my base unit. All right, and I need to turn this into milligrams to see if it's going to fit in here. So 3 hops to the milli prefix, 3 hops to the right. So I'm going to have that 2 grams. 2 is the same thing as a 2.0. So when I do my 3 hops to the right, 1, 2, 3, I'm going to have to add some zeros there. That's going to give me that 2 grams being 2,000 milligrams. All right, now you're going to test and ask yourself, is that 2,000 milligrams in that range? Is 2,000 milligrams in between 500 milligrams and 3,000 milligrams? Answer is yes, it is. Okay, so is the ordered dose safe? Yes, it is safe. So definitely just an example here of how you would apply that converting within the metric system to an actual nursing problem. I'm going to present this example as our first example to introduce a math skill called unit analysis. There are a lot of different ways that you can do dosage calculations in nursing. However, I believe that this unit analysis, which also can be called dimensional analysis or even factor label method, I think that this is a much easier method to doing these dosage calculation questions because this method removes the need to memorize specific formulas that would be used, for all different types of calculations. Now, are you still going to have to memorize things? Yes. In this example right here, you're going to have to know that 1 kilogram is 2.2 pounds. Okay. However, the unit analysis method is going to allow us to line up things that were given in the story problem, multiply them by things that we know to be true, and then cross out labels and ultimately ending with whatever the question is asking for. So in this question, it says your patient weighs 297 pounds. How many kilograms does your patient weigh? So I am given this 297 pounds. So that's what I'm going to start. And I'm going to always create fractions if I don't have a fraction given to me. So I'm going to do 297 pounds. I'm going to include the label. All right, turning it into a fraction, putting it over 1. All right, now what I'm going to do is I want my answer to be kilograms. I currently have pounds. So I've got to multiply by some type of conversion factor that's going to allow me to cross out those pounds. I know that 1 kilogram is equal to 2.2 pounds. So there's my pounds that match, which I want to be able to cross out. I would then be left with kilograms. Okay, so I'm going to multiply by this conversion factor. Now, I have a choice. Which one goes on top? Which one goes on the bottom? I have to put the 2.2 pounds on the bottom because think back to how you multiplied fractions in a basic math class. Something in the top with something in the bottom could cross out. So that 2.2 pounds needs to go on the bottom. The 1 kilogram needs to go on the top. Okay, from there, I can cross out pounds and pounds, which is what I want to do. The only label left now in the math problem is kilograms. So multiplying straight across the top there, I'm going to have a 297 kilograms. Multiplying across the bottom, 2.2 times 1 is just going to give me a 2.2. Okay, only label left is kilograms. How many kilograms? Yes, you are going to have to go one step farther, take a calculator, divide that out, and that's going to be 135 kilograms once you use your calculator. All right, now this one is just a relatively simple, straightforward problem. Some people are just going to know, oh, I take 297 and I divide by 2.2. That's fine. But I am going to use this unit analysis, this idea of multiplying by various conversion factors and crossing out labels in all of the other nursing problems, nursing calculation, dosage calculation problems that I'm going to do. So I wanted to show a simple example of that on how the process is going to work before we get into the harder questions. Taking a look at this example, the doctor orders Zantac 75 milligrams by mouth every 6 hours. So the abbreviations right there, you will have to memorize. They're not going to be needed for this question, all right, but you will still need to be able to interpret those abbreviations for other problems. So this is 75 milligrams by mouth every 6 hours for heartburn. The stock supply is Zantac 150 milligram tablets. How many tablets will you administer for the correct dose? All right, so they're telling us that our stock supply is 150 milligram tablets. Okay. Now, like I said, this by mouth every 6 hours, we're not going to need right now. But we are going to need the fact that the doctor ordered 75 milligrams. So the two pieces of information that you're going to have to pull out of this question are those two pieces of information. Now, using this unit analysis idea, it will go really far for you if you can remember that a lot of times you only have to take what is ordered and multiply it by what's available. Okay, so I'm going to start with what is ordered, and we're even going to call it that. We're going to say, okay, we're going to start with what is ordered. All right, well, what is ordered? 75 milligrams, okay? So I'm going to, again, use that fraction because I want the unit analysis. So I'm going to go 75 milligrams over 1. All right, I'm going to multiply it by something else, a conversion factor, something I know. In this case, I'm going to multiply it by what is available. All right, the stock supply is 150 milligram tablets. So the way I'm going to write this, since my question says how many tablets, my answer has to be in tablets. Well, right now I've got milligrams. This is in milligrams. I need those milligrams to go away. So every tablet, one tablet, okay, we're just going to go one tab there, is 150 milligrams. So that way I am causing the milligrams to line up in opposite places. I got a milligrams in the top. I got a milligrams in the bottom. When I cross those out, I have tablets left. That's my only label. So then I'm going to multiply straight across the top, 75 times 1. Okay, multiply straight across the bottom, 150 times 1. I've got milligrams as my, tablets as my only answer there. You're going to then grab your calculator, 75 divided by 150. That's going to give you a half of a tablet. All right, so remembering that nurses are leaders, not followers. So if I wanted to write this as a 0.5, I would definitely need to go 0.5 tablets. All right, this is the 0 in front. If you were to leave that out and just write it as 0.5, that could easily be misread as 5 tablets. So we want a half of a tablet, 0.5 tablets. But this was a straightforward unit analysis problem, relatively simple. You take what is ordered, multiply by what is available. And later on, as we maybe have to do 2, 3, 4 things in some of these problems, you may not know where to start. So one of the best places to start, especially if it's a complicated one and you don't know where to start, look at what's been ordered, look at what's available, and start with that conversion factor and see where it takes you. You may then have to do other things, but this is a really quick first step that works a lot. In this example, I went ahead and highlighted some important pieces of information. So as you are reading the question, sometimes it helps to do that. All right, Q-Flex is available as 3 grams per milliliter. So it's available in this quantity. The doctor orders 500 milligrams. So that's what's being ordered. So that's an important concept. I did highlight this. This is every 8 hours intermuscularly. That's not going to be needed for this particular questions, but knowing this abbreviation and what it stands for will be handy in other questions. All right, how many milliliters will you give for the correct dose? Round to the nearest tenth. Okay, I have also on this one written down a conversion factor over here, something that you could have memorized and you could use this to answer this question. There is clearly more than one way to do it. I am going to show how to do this one using this conversion factor as opposed to the mnemonic and the chart of moving the decimal point to the left or to right to do that metric conversion. Just a different way to approach the problem. All right, now as always, it's going to be good to start with what's ordered, multiply it by what's available. So if we start the process here with what is ordered, okay, so we come back up here. All right, what was ordered was 500 milligrams. So we're going to write 500 milligrams, and then we need to turn that into a fraction. So 500 milligrams over 1. We're going to multiply that by what is available. So then I'm going to come up to the story problem, and I'm going to see what's available. Okay, the medicine is available as 3 grams per milliliter. Okay, now you've got to decide where you're going to place things. Okay. Grams and milligrams are not going to cross out. So therein lies the problem. I can still use unit analysis if I use this conversion factor later. Now, the question is, how many milliliters. So I have milliliters here. I want that to be my answer. I am going to ultimately need both milligrams and grams to cross out. So if they are on the same spot, if I write 3 grams over 4 milliliters, the grams and the milliliters are on this, both on the top. I'm not going to be able to cross them out. So when I choose to write what's available here, I'm going to choose to put the 3 grams on the bottom. Milligrams and grams are on the opposite location right now, so I will be able to cross both of those out eventually. And the 4 milliliters is going to go on the top. All right, now in the past, we've just been able to do what's ordered times what's available. These two labels cross out and you've got your answer. This one is a little bit more. Since what was available was given to you in grams, the order was in milligrams. Okay, so you can do that by using a conversion factor. So I could multiply by a conversion factor, which is what I'm going to do. So conversion factor. All right, and again, I'm going to multiply by, I know that 1 gram is equal to 1,000 milligrams. All right, grams are on the bottom here, so I need grams on the top for those to cross out. If I put the grams on the top, that'll force the milligrams on the bottom, and the milligrams will be able to fall out. So I'm going to have 1 gram over 1,000 milligrams. All right, then we're just going to go through and cross out our labels to show they do cross out. Milligrams is on top, milligrams is on bottom, they cross out. Then I can look at my grams on the bottom here, grams on the top there, they fall out. So now at this point, the only label I have left is the milliliters, which is what the question is asking for. So I'm going to multiply straight across the top, multiply straight across the bottom. 500 times 4 is going to give me 2,000. All right, milliliters, I'm going to go ahead and put that label in there. Multiplying across the bottom, 3 times 1,000 is going to give me 3,000. Okay, now at this point, it does say round to the nearest tenth, so we should have some indication here that when I divide, you could at this point just go ahead and grab a calculator. 2,000 divided by 3,000. You could also use a little bit of math knowledge here. 0 on top with a 0 on the bottom crosses out, 0 on the top with a 0 on the bottom. Okay, you can cross out all those zeros, so you're looking at 2/3, in which case some of you might have 2/3 memorized. If not, 2 divided by 3, 2,000 divided by 3,000. That's going to give us a 0.6. Repeating, if I'm going to round to the nearest tenth, some of you might need to see that decimal written out with a few more numbers in there to be able to get the rounding appropriately. If I'm rounding to the nearest tenth, this number's in the 10th spot. The number to the right is going to tell you whether or not you round up or not. It is bigger than 5. So when this is bigger than 5, then we make the number in the 10th spot round up. So then that's going to be a 0.7. Now, if we keep with the nurses are leaders, not followers. Okay, so I need to have leading zeros. So I do need to write this as a 0.7 and then milliliters. All right, because if I don't, if I just were to write 0.7, that could, the decimal point might not be visible and clear, and someone might think it was 7 milliliters. So we go with that phrase, nurses are leaders, meaning I need to include leading zeros, not followers. I don't put the extra zeros on the end of the number. All right, a nurse is caring for a patient who weighs 110 pounds. The doctor ordered ranitidine, 75 milligrams, POBID, by mouth, twice a day. So there's, again, some abbreviations you're going to have to know. The medicine is available as ranitidine, 150 milligrams per 5 milliliters. Okay, so all the information that we need. So for our part A, we're going to do 3 parts to this. How many milliliters will be given per dose? All right, how many milliliters will be given per dose? All right, so again, we're going to go with that same pattern. We're going to take what was ordered and multiply that by what is available. Okay, so what was ordered was the 75 milligrams. Okay, so I'm going to go 75 milligrams over 1. I'm going to go ahead and label that as ordered. Okay, I want to multiply that by whatever I have that is available. All right, the medicine is available as 150 milligrams per 5 milliliters. Okay, so how am I going to line this up? I want to make labels cross out. All right, it's available. I've got milligrams and milliliters. My first one has milligrams. So the only part that matches is the milligrams. I need the milligrams then on the bottom so it will cross out. So I'm going to write the 150 milligrams on the bottom. I'm going to write the 5 milliliters on the top. All right, that's going to allow me to cross out milligrams and milligrams. Take a look at everything that's left. The only label that's left is mLs. That's what the question asked for. How many milliliters will be given per dose? All right, so it now is a straight multiply across the top, multiply across the bottom. 75 times 5 will be 375 milliliters on top. 150 times 1 is 150 there on the bottom. Straight divide here, 375 divided by 150 is going to give me 2.5, and this is milliliters, all right, per dose. Okay, so every time I give it, 2.5 milliliters per dose. All right, now let's take a look at this. How many total milliliters will be given per day? All right, now for that, this is where you have to have this BID memorized. All right, you've got to know what that abbreviation is. That abbreviation is twice a day, 2 times a day. So then that means I'm going to take 2.5 times 2, and that's going to give me 5 milliliters per day. All right, so BID twice per day. All right, now we're ready to take a look at part C. Restated the question up here at the top, and we're going to take a look at our part C. The recommended safe dose for ranitidine is 1.5 milligrams per kilogram to 3 milligrams per kilogram POBID is the ordered dosage within the safe range for this patient. All right, now the thing is we're going to come up here and we're going to look at what they gave us for the patient's weight. It's 110 pounds. All right, the recommended safe dose is in kilograms. So before I can even figure out whether or not it is a safe dose, I'm going to have to convert that 110 pounds to kilograms. And again, some of you are just going to realize that you're supposed to take 110 divided by 2.2, and that's going to give you your kilograms. But for those that do not see that easily, we can use the unit analysis. So we can say 110 pounds over 1. We'll multiply it by our rate that we have memorized here, that 1 kilogram is 2.2 pounds. We're going to choose to put the pounds on the bottom. So 2.2 pounds and 1 kilogram. Okay, that's going to show us that, yes, division really is what is needed here. Our pounds are going to cross off, so we'll have 110 kilograms on the top. Multiplying across the bottom, we'll have that 2.2. So that does show us to take the 110 divided by 2.2. That's going to give us 50 kilograms. All right, so the patient weighs 50 kilograms, okay? Now, what we're going to do is we have got to see if this is it's going to fall in here. So what we're going to do, I'm just going to do two conversions here, 2 different unit analyses. I'm going to do a unit analysis on the lower end of the range. I'm going to do a unit analysis on the higher end of the range, and then see if the prescribed dose, which was the 75 milligrams, falls in that range. Okay, so let's do our lower range first. All right, again, I'm going to use the unit analysis. So my lower range here is the 1.5 milligrams per kilogram. All right, and then I'm going to include the person's weight, which was 50 kilograms. I want those kilograms to cross out. I'll be left with just milligrams, and that's what the order was for. It was in milligrams. So I'm going to multiply this by the 50 kilograms, the patient's weight, over 1. That's going to let me cross out kilograms and kilograms there. So multiply straight across the top, multiply straight across the bottom. I'm just going to get a 1.5 times 50, which is going to be a 75 milligrams. All right, now I'm going to go ahead and I'm going to do the higher end of my range. So my higher range, all right, just to be safe, make sure this is going to fall in here, I'm going to take my 3 milligrams per kilogram. So 3 milligrams per kilogram. Again, I want to consider the patient's weight. I'm going to multiply it by the 50 kilograms so that my kilograms cross out. So 50 kilograms over 1. I've got kilograms on the bottom, kilograms on the top. That's going to cross out. I'm going to multiply straight across the top. 3 times 50 is going to be 150. The only label there is milligrams. So my range is between 75 milligrams and 150 milligrams is the safe dosage. All right, and what was ordered was the 75 milligrams. It is within this range. So then the answer to the question is yes. Is the ordered dosage within the safe range for the patient? Yes, it is. Okay, so in this example, we're going to take a look at calculating a patient's intake and output. All right, I do have a little helpful chart here with some things highlighted that correspond to things that I've highlighted in the question. All right, probably the number one important thing about this to remember is whenever there's ice chips or ice cubes involved, you have got to remember that they melt at 1/2 the original volume. So if a patient takes 240 milliliters of ice chips, you're going to only add in half of that, so 120. All right, so everything that is in pink here, all right, even though different shades of pink there, that's all intake, all right? The patient is NPO, nothing by mouth, for breakfast. For lunch, the patient was allowed to take 240 milliliters cup full of ice chips. The patient vomited 180 milliliters at 1300 hours and voided 100 milliliters at 1330 hours. At 1400 hours, the patient took 2 tablespoons of gelatin and a half a glass of apple juice. Calculate the patient's intake and output. Okay, so I highlighted everything that was an intake in pink. What I did on the outtake was in orange because you need to keep it straight. Sometimes you'll just be asked for one or the other in your questions, but this particular question asks for everything. So I'm just going to start making a list and add things up. All right, so intake. All right, so I said all of the intake was the pink. So 240 milliliters of ice chips, but remembering we have to include only half of that. That's going to be 120 milliliters. All right, 2 tablespoons of gelatin. All right, so I'm going to come down here to my chart. This is something that you would have memorized. 2 tablespoons, okay, is how much gelatin we had, but 1 tablespoon is 15 milliliters. So if the person ate 2 tablespoons, you're going to have to double this number, so it'll be 30 milliliters. So I'm going to put the 2 tablespoons right there, all right, and then we're going to write the 30 milliliters there, remembering to double what you had memorized being 1 tablespoon. All right, and then the last thing is a half a glass of orange juice, or sorry, half a glass of apple juice. All right, a glass typically is 8 ounces, all right, which is 240 milliliters. We're going to do this in milliliters. Half of a glass would mean I only need half of the number of milliliters. So half of 240 is 120. Okay, so I'm going to write down half glass, just so we remember that it was half glass where we got that number, and it's 120 milliliters. Okay, so add everything up. All right, so that's going to be a 0, that'll be a 7, and then a 2. So intake 270 milliliters. Okay, now we're going to work on the output. All right, I highlighted everything that was an output in orange. We had 180 milliliters at 1300. Okay, so I'm going to put 180 milliliters. All right, and then we voided 100 milliliters at 1330. So we'll add to that another 100 milliliters, and that's a total of 280 milliliters for the output. All right, so pretty much a straightforward question. They can make this question a little bit more challenging if they don't give these to you in milliliters. Okay, they could give things to you in ounces. They wouldn't have to say a half a glass of apple juice. They could give it to you in ounces. All right, if your answer somewhere down here on the key points, all right, intake and outputs are calculated in milliliters. Okay, so that's something you should know. If they give you things in your question that's in ounces, you're going to have to do some conversions to get them into the milliliters. All right, but other than that, these type of questions are pretty straightforward. You're just adding up the intake, adding up the outtake, and then just always be sure and read that question and only answer what they ask. If they only ask for intake, then that's the only thing you need to provide. If they only ask for the output, that's the only thing you need to provide. All right, in this question, we're going to be taking a look at determining whether or not a dosage that has been given is a safe dose or not. So we've got a child that weighs 77 pounds, so I highlighted that. That's an important piece of information. All right, this child is started on oral morphine solution that is 20 milligrams by mouth every 3 hours. The recommended dose of oral morphine for children that are less than 50 kilograms is a 0.3 milligrams per kilogram every 3 to 4 hours initially. All right, so to begin with, this part A, to be able to answer this question, says what is the maximum safe dose based on the drug literature for this child? All right, so the fact that they gave us the weight in pounds and the recommended dose is in kilograms, you're going to have to do a conversion there. All right, you can, if you are really good at your conversions, you don't have to use unit analysis. You can just take 77 divided by 2.2. All right, but if you do want to see that done in a unit analysis form, our step one would be to take the 77 pounds and then put it over 1, and then multiply by the conversion factor, putting those pounds on the bottom, which would be 1 kilogram over the 2.2 pounds. Okay, pounds are going to cross out. All right, multiplying straight across there, that's going to give you 77 kilograms divided by the 2.2. So that's why I said if you just can easily convert pounds to kilograms by dividing by 2.2, that works. The unit analysis also works. All right, this is going to give us a weight of 35 kilograms for the particular child in this problem. All right, so that's kind of step one. Okay, now step two, we need to actually answer this. What is the maximum safe dose based on the drug literature for the child? Okay, so my step two then is going to be, okay, I'm going to take the 35 kilograms for this particular child. All right, so we've got 35 kilograms. Again, I'm going to set this up for unit analysis, so putting that over 1. All right, and then I'm going to multiply it by the safe dose. All right, so let's identify this here, safe dose. Okay, coming back up here, all right, the recommended dose for children that are less than 50 kilograms, definitely less than 50 kilograms, is 0.3 milligrams per kilogram, okay, every 3 to 4 hours. So I'm going to multiply, again, using that unit analysis. I want the kilograms on the bottom, so they will cross out. So I'm going to put kilograms down here. I'm going to put the 0.3 milligrams up there. Kilograms and kilograms are going to cross out. So basically, it's a matter of multiplying 35 times 0.3. The only label in the problem is milligrams. That's going to give us a 10.5 milligrams every 3 to 4 hours. Okay, so that is the maximum safe dose based on the literature for this child. Now, part B, is the ordered dose safe? All right, well, I'm going to come back and I'm just going to write it down so we have something written down here. What was ordered for this child? The child was started on 20 milligrams by mouth every 3 hours. So 20 milligrams by mouth every 3 hours. Okay, well, 20 is way more than the maximum safe dose of 10.5. All right, so to answer the question, is the ordered dose safe? Answer is No, it is not safe. All right, in this example, we're going to take a look at how we would go about reading a medicine bottle. Okay, what kind of information is on there, their medication labels. In general, you're going to have the name. All right, you will have, like, for instance, 250 milligrams per 5 milliliters. You're going to have directions for mixing. You're going to have dosage. This is clearly a powder, and you've got to add water to mix it up. All right, so when it's reconstituted, each 5 milliliters contain. So in overall, you're going to be reading the entire label, pulling out things like the trade name, the dosage strength, instructions for mixing, the generic name, okay, expiration date down here in the corner, keep tightly closed, shake before using, must be refrigerated, discard after 10 days. So there's lots of pieces of information on here that's going to be helpful. However, what is the question asking for? You're going to be probably given some questions and then shown a label, and then they may ask you just, what is the trade name? What's the dosage strength? Is there an expiration date? All right, or this one, which goes a little bit more into the dosage calculation. All right, it says what was ordered. Well, 375 milligrams by mouth twice a day is what's ordered here. All right, the nurse will give what? All right, so we're going to stick with that. Okay, what was ordered? All right, and then what's available over here. So what was ordered? We'll go ahead and set up ordered. Was the 375 milligrams. All right, setting this up for that unit analysis, we'll put that over 1, okay? And then we're going to multiply that by what was available. So what's available? All right, and we've got 250 milligrams per 5 milliliters. Again, I want milligrams to cross out, so I'm going to put that 250 milligrams on the bottom. I'm going to put the 5 milliliters on the top. That's going to allow me to do the unit analysis, get those milligrams crossed out. We're going to multiply straight across the top, multiply straight across the bottom. 375 times 5 is going to give me that 1875 milliliters. And then multiplying across the bottom there will just be the 250. All right, grabbing a calculator, 1875 divided by 250 is going to be 7.5 milliliters. All right, so the math on this one is pretty straightforward because it is focusing really on the dosage calculation part. All right, just kind of incorporating, okay, how do we read this label? All right, but just know you could have other questions pertaining to reading the label. There is lots of information on there. You just kind of get used to reading the information, interpreting it, and then if it's just a straightforward question, answering directly from the label. All right, in this example, it's really more of an exercise than an example. We're trying to focus on safety with our dosage calculations. We're making, clinical judgments. All right, so they are going to give you some questions where you have a situation. All right, and then it'll be a multiple choice question. You'll have to go through and justify, think about each one of those, which one would be right, which one would be wrong. And then obviously, if you're in a study group with friends, you could discuss, you could have some rationale why you are picking or not picking each of these. All right, so let's go through and read this here. All right, it says the nurse has an order to administer morphine, 3 milligrams, IV stat, okay? So that's an important thing right there, okay? We got to know what's being ordered, okay? The nurse selects the following vial, so we got a picture of that, all right? In preparing to administer the ordered dose, is it important for the nurse to, all right, let's just go through all of them. A, give 1.5 milliliters of this drug using 2 vials. All right, so yes, while it is important, that you can do a calculation here, you can do some math, you can figure out what you would have to do, all right, but really, in all honesty, the very first thing before you should even do any math whatsoever is make sure everything corresponds. The order is for morphine, but the vial that was grabbed does not say morphine. All right, yes, they are both opiates. All right, they're in the same family, but it's not the same drug. All right, so there's no reason for you to start doing math and try to figure out if A is right, okay, because A is incorrect. B says call the pharmacy to double check the order. Okay, so before you take the time to call the pharmacy, you definitely should check the original order, and that's going to be found in the physician's order sheet. So you don't need to make that phone call to the pharmacy until you've checked the physician's order sheet. C says research the appropriate route of administration. Okay, that is important. All right, doesn't necessarily, the most important. It is important. You should always ensure that the available drug corresponds to that which is correct. All right, and then how you're going to administer. So everything has to jive up. But the question here is most important. All right, so D says not administer this drug. All right, in preparing to administer the ordered drug, it is most important for the nurse to not administer. All right, so D is our right answer, because why? Morphine was ordered. That is not the vial there. Okay, so this one was kind of straightforward, but could be easily overlooked. You could easily get stumped here, maybe pick, either C, because, yes, that is important. It's not the most important thing. All right, and if you get too caught up into, oh, this is a dosage calculation quiz, I got to do some math. All right, you don't necessarily need to do math on every question. So if you weren't paying attention to the names and you just started cranking out some math over here, all right, that could create a problem for you as well. So these are basically just think type of questions. Take each one of them. You can go in order. You don't have to go in order. Take each, choice, A, B, C, D, think it through. But again, I would not pick an answer until I have looked at all 4 answers first.